Hello and welcome to the Algebra Crash Course presented by LitZone. So this crash course is here to make your life easier for revision purposes and to help you prepare for upcoming examinations that you may be having this year. I know 2021 hasn't been a great start for the majority of us, and we're still in the same position as we were in 2020 with this whole quarantine. A lot of us are at home and just bored out of our minds, but this will hopefully just break down everything you need to know for GCSE Algebra and, to be honest, the secondary school in general for Algebra. So I will start from the beginning in each bit. Stuff that's higher based, so for levels 7 till 9, I will specifically say that this is higher. So let's get into what is in this Algebra crash course. So the Algebra crash course overview, we have the foundations of algebra, algebraic formula, solving linear equations, solving simultaneous equations, solving quadratic equations, inequalities, sequences, straight line graphs, other graphs, transformations of graphs, algebraic fractions, and using graphs, okay? So this is the overview of what's going to be in this playlist. I'm going to try and give you some tips and tricks and specific things that you need to know for your GCSE exams when it comes to the algebra topic. Why I like to specifically start with algebra is because it's one of the biggest topics in GCSE maths, and a lot of other aspects of GCSE maths involves you understanding the foundations of algebra and everything else to do with algebra and manipulating it, okay? So I'm going to try and give you some gems. The way I like to learn maths in general is through questions, so I'll probably be trying to do predominantly answering questions and showing you how I go about looking at questions. And yeah, hopefully this helps you with your exam revision. So let's get started with the foundations of algebra. So let's just get started. How we can describe algebra is by using letters to stand for values that we don't know or that we want to change, in a sense. And these values are what we like to call variables. So values that can be changed are called variables, right? The main information you need to know here is what terms are. So terms are just like groups of letters, or just a group in a sense. So for instance, like x squared or minus 3y or 8, those are all terms because they're all part of their own groups. This is part of the x squared group, this is part of the y group, and this is just part of numbers groups, okay? When you combine terms together, you get something called expressions. So for argument's sake, if I have x squared and I want to combine that with minus 3y, this here is an expression, okay? Now, something you've probably seen in your questions is something called an equation, right? An algebraic equation is similar to an expression, but you have something's equal to something else. So for argument's sake, like you have something like 8a plus 4 is equal to 20. And this can be solved. You can get a value for the a to make this whole thing correct. And the value for the a in this particular example will be 2, because 8 times 2 is 16, and 16 plus 4 gives you 20, okay? So that's an equation. And then finally, we have something called an identity. Identity, okay. So this looks something like this. So for instance, 4a times a gives you 4a squared. This has to always be true. That's what an identity is. It has to always be true, okay? And we're going to look into why this is true later on in the course. Right, so a big part of algebra is being able to manipulate it, yeah, with some finesse, with a bit of skill, right? So here we're going to look at simplifying expressions. And I've put down a note. This is very important, yeah? You can only add and subtract like terms. Now we're going to look at adding and subtracting algebra. Now like terms basically means terms of the same clique, the same group, right? If they're not part of the same group, you can't add them or subtract them. They don't want to mess with each other. So it's really important that you keep that in mind. So for argument's sake, if we have A plus A, they're part of the A clique, they're part of the A group. So you can add them together, which gives you 2A. Or if you have B plus B plus B, again, 3 of those are all part of the same group, they're B's, and it gives you 3B, right? Okay, we can now go a step further. If we have like 2A plus 5A, again, you got 2 lots of A's, right? A group, and 5 lots of A's, A group. So yes, you can add them together by just adding the numbers in front, the 2 and the 5. And 2 plus 5 gives you 7A. Voila. Let's mix it up. We've got 8T take away 3T. Again, you can pause the video if you want and try and figure this one out. Right, if you're back. So again, we have T groups, so they're part of the same group, so you can do this. You got 8 minus 3, which gives you 5T, okay? Now it's important, what you can't do under no circumstances is something like this. So you have like 3x plus 4y. I've seen so many people make this mistake. You cannot add these two things together. They aren't part of the same clique. They're not part of the same group. They've got different terms. They don't like each other. So you cannot do anything here. Nothing changes. It just remains 3x plus 4y, okay? You can't add letters that aren't the same, okay? Groups that aren't the same. Same as taken away. So if I give you like 4e subtract 2t, you can't subtract those two because, again, they're not part of the same terms. Not the same terms, they're not part of the same group. So it remains 4e minus 2t. Now, I've seen a lot of people make that mistake. If you can just remember that, you're Gucci, you're fine, okay? But if you don't remember that, you're going to be in a bit of a situation, okay? So again, really important to go over this point again. You can only add / subtract like terms, so same groups. You cannot do that if they are different. So boom, you may be asked this in an exam, or you may just have to do it as part of a question, okay? So you're asked to simplify 10f minus 3x plus 2f minus 2x plus 7. Right, so how I tackle this is I'll just look at the terms are the same. So we've got 10f and plus 2f, okay? Another thing I should also give you in terms of a little trick is that you should always look at the sign in front of your term. So this is not just a 2f, it's a positive 2f. Really important stuff. This is a positive 10f, okay? Keep an eye on that because a lot of students and people in general always, for some reason, ignore the signs, especially for some weird reason, the negative sign. I don't know why that gets no love, but I'm trying to give it some more love because it needs it, okay? So anyway, you look at the signs and you look at the groups and we bring them together. So we have now 10f plus 2f, and that gives you 12f, okay? So that's for the f's. Now we're going to look at the x's. So we got a minus 3x here and a minus 2x here, okay? And you can combine them again by doing minus 3x minus 2x, and you should know that's minus 5x because it's like you're adding negatively. And then also you've got a plus 7 left on its own, which you're just going to add to the end of this whole thing. So when you combine everything, you will have 12f minus 5x plus 7 as your final answer. And that is this whole thing simplified, okay? So this is your answer. And that can't be simplified any further because you cannot, like I said, combine terms that aren't the same, groups that aren't the same. You've got an F group here, an X group here, and a 7, a number group here. They cannot be combined. So this is your final answer. This is what you would write down as your answer. And in an exam, okay? Okay, I'm going to also backtrack a little bit here. You also need to understand when you see something like 5x, right? You need to understand what's going on between the 5 and the x. And what's going on here is that 5 is being multiplied by x. You've got 5 lots of x's, okay? Or you can just write x plus x plus x plus x plus x 5 times. 1, 2, 3, 4, 5. But, oh, what? That doesn't even look like an x down there. What's going on here? X plus x plus x plus x 5 times. 1, 2, 3, 4, 5. But that's a bit tedious. And if you have something like this, 452x, you may not get this, but you could. I don't expect you to do x plus x plus x 452 times, because no one's really got time for that, to be honest. So you just write 452 times x, okay? Right, so let's look at multiplying algebra and dividing some terms as well, because you need to be able to multiply and divide in order to simplify things as well. So if you have something like a times a, right, this gives you a squared, because you're timesing whatever the value for a is by itself. It's like doing, if say example a was 5, it's like doing 5 times 5. Yes, you can write 25, but you can also write that as 5 squared, because it's 5 times 5 is 5 squared, yeah? If we got given b times b times b, that gives you b cubed. And yeah, you also need to be able to manipulate this if you're dealing with the same kind of terms. So for argument's sake, if you have like a to the power 5 multiplied by a to the power 3, all you're going to do is add these two indices. We call these indices. We add these two indices together, and you have a to the power of 8. All right. Another example, it could be, let's mix up even a little bit more. So like, for instance, 5x to the power of 3 times by 2x to the power of 2, or 2x squared, right? So people will look at this and be like, oh no, I can't do this. You can try and do this. You can pause this video now if you want and try and do it. So I'll give you a moment. Right. So if you got that done, well done. If not, we're going to look at it. So what you do here is simple. You'll do 5 times 2 first, the numbers in front first, because it's easier, which gives you 10. And then you'll do x cubed times x squared. And how we did it before again is you add the indices together. 3 plus 2 is 5. So it'll be x to the power of 5. And that's your answer. Voila. Right, so dividing is kind of similar to multiplying. So for argument's sake, if we have x to the 8 divided by x to the 3, again, you'll just subtract these indices. So you have x to the 5, right? Or if we have y to the 7 divided by y to the 3, you'll again subtract these indices. So you have y to the 4. Now, the main thing to actually keep in your mind here, it's kind of similar to adding, subtracting, in terms of this kind of trick with adding or subtracting these indices only works if you have the same terms, the same groups. If you got given something like a to the 7 divided by b to the 5, you can't do that. You can't just take away the indices, because again, the groups are different. They're part of different cliques. A is the A group and B is the B group. So it just remains pretty much the same. A to the 7 divided by B to the 5. Okay. Also, another way you could see these questions in an actual exam is like this. So you could be given something like 10y to the, 12 divided by 5y to the, 7. So again, I'll give you a minute to try and work that out, try and simplify that down for me. Okay, so if you did that, well done. But let's get to it. So again, in this question, I'll deal with the numbers first. So you do 10 divided by 5, which is 2. And then I'll do y to the 12 divided by y to the 7. So again, here, because you're dividing, you take away the indices. And because they're both y's, you can actually do that. So you do 12 take away 7, which is 5. So it becomes y to the 5. And that's the answer, 2y to the 5. You see that? So we've simplified this to make our life easier. And that's what we like to do as mathematicians, make life easy.